Let's take a look at another way that we can use coordinate geometry to determine what kind of quadrilateral we're taking a look at. So I've gone ahead and already graphed my points. If you haven't done that, then you can pause the video if you're doing this with me. Otherwise, let's just go ahead. So I want to classify this quadrilateral, and even though we're not allowed to just say, oh, this looks like a whatever, and then use that as proof, I'm actually going to use that as my starting point. So looking at this, I have a feeling that this figure might be a rectangle. Now that, again, certainly doesn't prove that this is a rectangle, but it gives me an idea of where to start my investigation. So there's some things I would need to know about this figure in order to prove it's a rectangle, and one of those things I would need to know is that first it's a parallelogram, because a rectangle is a type of parallelogram. So step one, let's prove that this is a parallelogram, and we have different ways to do that. I have a different video on that. I think the best bet for this one is going to be to find the slopes of the sides in order to figure out if this is a parallelogram or not. And then we'll go ahead and go one step further and see if it's a rectangle. So find the slopes. We could do that a few ways. We could calculate the rise over run, which is what I'm going to do because we can just do that visually. We could also do the slope formula, y1 minus y2 over x1 minus x2. Or if we have the DMS program or some other program to use, we could use our calculators to do that. So let's find the slopes. And what I want to show is that opposite sides have the same slope, which would mean they're parallel. So taking a look at our slope from A to B, I'm going to calculate my rise, and I can see that I count 4 spaces up for my run, or for my rise, and 2 spaces to the right for my run. So my rise over run is 4 over 2, which gets me a slope of 2 for that side. If I do the same for points D to C, I can again see that I have a rise of 4 and a run of 2, which gets me 2 for that. That's good. I've proven that those two sides of the figure are parallel because they have the same slope. That doesn't make it a parallelogram. That makes it a trapezoid. We have one set of parallel sides. But let's go ahead and find the slopes from A to D and from B to C. I can see that on those I've got a rise of 1 and a run of 2. And since that's a negative direction, a negative sloped line, I'm going to say that's a slope of negative 1/2. And same thing again up top. I have a run of 2, a rise of negative 1, so I've got a slope of negative 1 over 2. And so again, I've proven now that those sides are parallel because they have the same slope. So I found the slopes, which means I do in fact have a parallelogram at least, because, give me a second here, because I've got 2 sets of parallel sides, which means we're not yet at a rectangle, but at least we're a bit closer. We do know that we're at least in the parallelogram family, of which a rectangle is one of our descendants, I suppose. So step 2, let's go ahead and actually figure out if this is actually going to be a rectangle. To do that, I have to know that I've got 4 right angles. So let's go ahead and prove that the sides are perpendicular to each other. If I can prove the sides are perpendicular in our right angles, then I've proven that this is going to be a rectangle. So to be perpendicular, we need slopes that are opposites. Let me make a little note about this. So to prove that lines are perpendicular, we need slopes that are opposite, meaning one's positive, one's negative, and we need them to be reciprocals, meaning we've taken the fraction and flipped it around. So let's take a look at like this corner right there between side AD and side DC. So the slopes there are negative 1/2 and positive 2 over 1. If I can prove that that's a right angle, if my slopes are opposite reciprocals, they're all right angles, which means I have a rectangle after all. So we need the slopes to be opposite. I can see they are. One's negative and one's positive. I need the slopes to be reciprocals. Take the fraction and flip them, and I've got that. So here's what I've done then. I know for sure that's a right angle. My lines are perpendicular because the slopes are opposite reciprocals. That's going to make all of them right angles. Since we've already proven it's a parallelogram, we know that opposite angles are congruent, and that consecutive angles are supplementary. So I've proven it's a parallelogram. I've gone ahead and showed that I have right angles, which means this figure is definitely going to be a rectangle. I suppose some of you may be thinking there's one more shape this could be. Another parallelogram that has 4 right angles could also be a square. So I can take a look at this figure, and I know we're not supposed to judge by looks, but I can see for sure that this is not going to be a square because those sides are definitely not the same length. If I wanted to prove that beyond the shadow of a doubt, I could go ahead and find the distance of all 4 sides and show they're not the same. But I can definitely see that those sides are not going to be congruent. If I thought they might be, I couldn't say, well, it looks like a square. I'd have to prove it. But I can definitely prove this is not a square just by I can tell those sides are not close to being the same length. So this figure is a rectangle.